So, Sam the math tutor is here again, and I want to continue our work on logarithm. So, we're looking at logarithm equation. Logarithm equation. This logarithm equation must be understood from the perspective of indices. We can turn every logarithm equation into indices, and we can turn all indices equation into logarithm. So, that's what I will be introducing first before I go into the full concept of what we are learning today. So, what do I mean? If I have log base x with an argument m is equal to y, what will happen is that what we have on the other side, we call it the exponent. This is the exponent. I think I've explained that. Call it the exponent. So the base carries the exponent, then it will be equal to the argument. Base to the power of exponent equals argument. So base to the power of exponent is equal to argument. That is how we change logarithm to indices. Base to the power of exponent equals argument. So in short form, we can have it like this: b to e equals a. So that's how we change indices to logarithm, or logarithm to indices. So let's take our first example. So I've solved the equation log base 10. Solve the equation log base 10 log 4p squared plus 1 base 10 minus 2 log p base 10 minus log 2 base 10 equals 1. So to the left hand side, we apply the first law and the second law, maybe the first and the second law of indices, or firstly, we have a coefficient here that could turn to power. So we change the coefficient to power. So let's start with that. We have log of 10, 4p squared plus 1 in the bracket. So if the coefficient turns to power, we have log p squared minus, we have minus here, then minus log 2 base 10 is equal to 1. So from here we can apply the second law. So, and the second law says when we have subtraction, we divide. As far as all the bases are the same. So from here I can have 4p squared plus 1 over p squared. Then we have another division. Or, okay, let's do it like this. Let me do it in a better way so that we understand what we are doing. Very important. So I will write what I have here first. Log p 4p squared plus 1 base 10. I will simplify this. I will simplify log p squared base 10 minus log 2 base 10. I will simplify that first. Why I still leave this like this. So I have log minus log. So if I use second law to simplify that, it turns to p squared over 2 base 10 is equal to 1. Now from here, I then simplify these two. So I will have log base 10 4p square plus 1 divided by p square over 2. Or you can also have it like this in a better way. Put this in a bracket divided by p square, because over is the same thing as division. P square over 2, close p square over 2, close the bracket, is equal to 1. So from here I have log base 10. This will be p 4p square plus 1 times 2 over p square is equal to 1. When we multiply, we reverse the fraction. So we have log 2 brackets 4p square plus 1 all divided by p square is equal to 1. So don't forget it's base 10. So we have log, we open up the bracket there, 8p square plus 2 all divided by p square base 10 is equal to 1. Don't forget our formula. We have b raised to the power of e equals a. That is, base to the power of exponent is equal to a. Our base here is 10. The exponent is 1. The argument is 8p square plus 2 over p square. So that is the same thing as 10 is equal to 8p square plus 2 all divided by p square. By cross multiplication, we then have, so we are cross multiply. We have 10, this should be p square from our previous one. 10p square is equal to 8p square plus 2. Collect like terms, we have 10p square minus 8p square is equal to 2. That will be 2p square equals 2. So if we divide both sides by 2, divide both sides by 2, we have p square is equal to 2 over 2, which is 1. So p square is equal to 1. So if we take the square root of both sides, p will be square root of 1, plus or minus, because anytime we take root, the answer can be positive or negative. So plus or minus, so our answer is plus 1 or minus 1. The option can provide one of these two answers. So, okay, it's a theory question. So, answer is plus or minus 1. So, we check our second example. So, the example we have here is a Y question, 2006 Y question, which is a combination of an indical equation and logarithm equation. So we are finding the value of x and y for 2 root to the power of 2x minus 3y equals 32, and also log x base y equals 2. So we simplify the two. We use the laws of indices to simplify 2 raised to the power 2x minus 3y equals 32. Then we use the laws peculiar to logarithm to simplify log x base y equals 2. So if we are simplifying the first equation, so we have to put the two of them, the two expressions in the same base. That will be 2 to the power of 2x minus 3y is equal to, we put them in the same base. So we are expressing 32 in base 2. 32 will be 2 raised to power 5. So from here we can equate the powers. Since the bases are equal, we equate the power, equate the powers. So we then have 2x minus 3y is equal to 5. This will be our equation 1. And for the second one, we have log x base. So we initially explained that the base will carry the exponent. So according to our law, how we turn logarithms to indices, we have the base to the power of the exponent is equal to the argument. B is the base, E is the exponent, and X is the argument. Argument, it should be A. A is the argument. So according to what we have here, the base for the logarithm is y. The exponent for the logarithm equation is 2, and the argument is x. So we then have y to the power of 2 is equal to x. So we have x is equal to y raised to the power 2. So this is equation 2. So we then have simultaneous equation, and this simultaneous equation is one linear, one quadratic. One linear, one quadratic. So equation 1 is 2x minus 3y equals 5, and equation 2 is x is equal to y squared. Equation 2. So we will substitute equation 2, we substitute x is equal to y squared in equation 1. So I'm replacing all the x in equation 1 with this value. Therefore, we have 2y squared minus 3y is equal to 5. This is a quadratic equation, so I arrange appropriately. I have 2y squared minus 3y minus 5 equals 0. So from here, I solve the simultaneous equation. We are finding we need to first multiply this and this. So that will give 2y squared times minus 5 over minus 10y squared. So I'm looking for two values. Whose product is minus 10y squared. So I'm looking for two values whose product is minus 10y squared. And the same two values, their sum or difference is minus 3. Minus 3y. So that will be minus 5y times 2y. This will give minus 10y. If I multiply this by minus 10y squared, and the difference between this, or the sum, is minus 3y. So that we use these two values to replace minus 3y. So we then have 2y squared minus 5y plus 2y minus 5 is equal to 0. Then we factorize. So 2y comes out. We then have y. Sorry, is y that is common to both of them. So bring y out. We have 2y minus 5. Then positive 1 is the only figure that can divide 2y minus 5. So positive 1 comes out, we still have left with 2y minus 5. Since what we have in the two brackets are the same, therefore we're on track and our answer is correct. So from here we have y plus 1 in a bracket 2y minus 5. So we equate both to 0. Y plus 1 is equal to 0 and 2y minus 5 is equal to 0. So from here, y will be equal to negative 1 and from here, y is equal to 5 over 2. So those are the values of y. Now to get the value of x, we have initially said that x is equal to y squared. So from here, we substitute the values of y into the expression so that we can get x. So for the first one, when y equals minus 1, so x will be equal to minus 1 squared, which is equal to 1. And when y equals 5 over 2, x will be equal to 5 over 2 squared, which is 25 over 4. 25 over 4. So our answer, according to coordinate x, comma y, will be equal to, for minus 1, when x is 1, y is minus 1, and or when x is 25 over 4, y is equal to 5 over 2. So that is the answer to the question. So we have another question here, the JAM question, UTME question. We have log base 4y minus 1 plus log 1 over 2x base 4 is equal to 1, and log 1 plus y plus 1 base 2 plus log x base 2 equals 2. So both are logarithm equation. So I have log is 4 y minus 1 plus log is 4 1 over 2x equals 1. So since the bases on both sides here are the same, therefore I can apply first law. And with first law, we'll write one of the base while we multiply the argument. So it will be y minus 1 times x over 2. This is the same thing as x over 2. Both equals 1. Then we can now apply our equation that changed on logarithm equation to exponential or indices equation. So we have a base to the power of the exponent is equal to the argument. So b is base, e is exponent, and a is argument. So the base in this question is 4, the exponent is 1, and the argument is y minus 1 x over 2. So from here, we have 4 to the power of 1 is equal to y minus 1 in brackets x over 2. So if I multiply this, I have 4 is equal to y minus 1 in brackets x over 2. So by cross multiplication, I have x in brackets y minus 1 equals 8. by cross multiplication. So that's for the first equation. For the second, where we have log y plus 1, log y plus 1 base 2 plus log x base 2. Y plus 1 base 2 plus log x base 2 equals 2. So for this, I will apply first law to the left hand side of the equation. So according to first law, we will write one of the bases and multiply the exponent or the argument. Multiply the argument, so equals 2. So I've applied first law to this. Then I apply the law that turns logarithm to indices. That is the base to the power of the exponent equals the argument. The base in this question is 2. The exponent is x plus 1 in bracket x. And the argument is x plus 1 in bracket x. And the exponent is 2. So the base is 2. The exponent is 2. Then the argument is y plus 1 in bracket x. So we have 2 to the power of 2 is equal to y plus 1 in bracket x. So from here, our 4 is equal to y plus 1 in bracket x. If I make x the subject from here, make x subject, I have 4 over y plus 1. That means I will be dividing both sides by y plus 1 is equal to y plus 1 in bracket x over y plus 1. So y plus 1 takes out y plus 1. So I then have x is equal to 4 over y plus 1. So if I combine it with the previous equation we have, this equation here, where we have x in brackets y minus 1 equals 8. So this is from equation 2. We say from 2. Why from equation 1? From equation 1, we had 8 is equal to x in bracket, this is equation 1. 8 is equal to x in bracket y minus 1. So 8 is equal to x in bracket y minus 1. So I can also make x the subject from here by dividing both sides by y minus 1. So that's 8 over y minus 1 is equal to x in bracket y minus 1 over y minus 1. So y minus 1 will take out y minus 1. So x is equal to 8 over y minus 1. So from here, this is what I have from equation 1. So since equation 1 and 2, equation 1 is x is equal to 4 over y plus 1. That's 1. And x is equal to 8 over y minus 1 is equation 2. Since they are equal to the same thing, I can find their value. I can find the value of y by equating x to x, equating 1 to 2. The right hand side of equation 1 will be equated to the right hand side of equation 2. That will equate x in 1 and 2. So I will have 4 over y plus 1 is equal to 8 over y minus 1. So by cross multiply, I have 4 in brackets y minus 1 is equal to 8 in brackets y plus 1. So I have 4y minus 4 when bracket is open 8y plus 8. Collection of like terms, 4y minus 8y is equal to 8 plus 4. So here we have 4y is equal to 12. Therefore, y equals 3. So y is equal to 3. I can get the value of x. X is equal to 8 over y minus 1 in 2. This is equation 2. So if I substitute the value of y here, so we have x is equal to 8 over 3 minus 1. 3 minus 1 is 2. Therefore, x will be equal to 4. So our answer, x comma y is equal to 4 comma 3. So that is our second example on equation. So we continue our example. We look at this example now. Solve the equation log 10 log base 10 x minus 8 square is equal to 2 minus log x plus 1 square over 10. So I have to simplify the left hand side because there are two expressions there. And if I must simplify the left hand side, I must ensure that this is changed to a figure that is in log base 10. So which figure can represent, which figure that has base 10 can represent 2? As we know that when the base and the exponents are the same, the answer is equal to 1. So if I have 2 log 10, this is still equal to 2. So I can use that to replace 2 here. So I will have log x minus 8 in brackets square base 10 is equal to 2 log base 10. Argument is also 10. Then log x plus 1 square base 10. So from here, I have log x minus 8 square base 10 will be equal to, I take the coefficient to the power. So we have log 10 raised to power log 10 raised to power 2. If we are making the coefficients, if we are turning the coefficient to power, we have log 10 raised to power 2 minus log 10 in bracket x, log base 10 in bracket x plus 1 raised to the power of 2. So from here, I have log x minus 8 square base 10. Then from here, I can use second law. So in second law, we write the same base. Then the two exponents will be divided when we have subtraction. So I have 10 square divided by x plus 1 square. So now the two logs can take out each other. So I'm left with x minus 8 square. And since the two values here in the bracket carries power, it can be written as 10 over x plus 1, 10 over x plus 1, all in bracket square. So this is applicable when we have a numerator and denominator with brackets, so with power. They carry the same power, so I can write the two of them together with a single power. So from here, take root of both sides, take square root of both sides. So we then have, if I take square root of both sides, so the square root, we take out the raised to power 2. They have square root here. So we then have x minus 8 is equal to 10 over x plus 1. So by cross multiplication, cross multiply, cross multiply, and we have x minus 8 in brackets x plus 1 equals 10. So if I open up the bracket, I have x squared minus 7x minus 8. I take this 10 to the other side, minus 10 equals 0. So I then have x squared minus 7x minus 18 is equal to 0. So two numbers, we are looking for two numbers. One product is minus 8, and the same number when simplified will give minus 7. So the numbers that can give minus 8 is minus 9 and 2 and positive 2. So which of them will give minus 7? Minus 9 and positive 2 and 9 minus 2. The product of these two numbers is minus 18, but only this will give minus 7. This will give positive 7. So that's not the answer. So the answer to this is minus 7. The answer to this is plus 7. And we need a number that could give minus 7. So minus 9 and 2 is replacing minus 7. So I have x squared minus 9x plus 2x minus 18 equals 0. So put them in brackets. The factor for this is x, so we have x minus 9, and the factor for this is 2x, so we have x minus 9 equals 0. So we then have, the factor here is not 2x, it's 2, sorry. So 2 divided 2x, we are left with x minus 9. So the brackets are the same, therefore we have x plus 2 equals 0, and x minus 9 equals 0. So from here, x will be equal to minus 2, and x is equal to 9. So our answers are minus 2 or 9. So thanks for staying tuned. Thanks for listening. I hope you have learned one or two things. Please like, share, and subscribe. The little you do help in supporting and promoting this work. Thank you, and have a great day.